So we have a political candidate has asked you to conduct a poll to determine what percentage of people support him. If the candidate only wants a 2% margin of error at a 95% confidence level, what sample size is needed? Now, there is a good example in the textbook. Example 8.14 goes into a little more detail about where do we get our there's no probability given to us here, or no P, or our proportion estimate is not given to us. So whenever one's not given to us, we use 0.5. And of course, if P prime is that, then Q is 1 minus that, so we get 0.5. And the reason we do this, because if we multiply these two, we get 0.25, which is the highest of all the products of P and Q. For example, if P was 0.4 and Q is 0.6, we get 0.24, and 0.3, 0.7, 0.21, and so on. So this gives us the highest, which is what we want, because we want to make sure we have a sample size that's going to be large enough for our margin of error of 2%. So that's my error bound for the proportion is 2% or 0.02. So the formula I'm going to use is N equals, and this is given in your textbook, Z P prime times Q prime all over our error bound or margin of error squared. So we have everything that we need. Our error bound is at 0.02 squared. My P prime, and there's also a P hat that your book talks about it too, that these can be, P prime and P hat are the same thing. They're both the point estimates for our proportion. So we have our P, which is 0.5, and we have our Q. And all we need is this Z, and we're going to square it. So we need to figure out what our Z is. Well, that comes, we can figure it out because we know what our confidence level. We have a 95% confidence level. So remember, our Z is from a standard normal distribution. So that tells me quite a bit. So I want to find out what Z will give me a 0.95 area. So I'm going to use my calculator, and once you know a 95%, what the Z-score is for a 95% confidence interval or level, it's always the same. So once you don't have to calculate Z for a 95% confidence level. Okay, so let me bring my calculator back over here because we're going to use it. So let's look at what we have. So let's think about if I draw the picture here. So this part is our 95%. Okay, 95%. And so that leaves me with 5%. Well, remember, half is on this tail and half is in this tail. Okay, so we take that 5%, or look at our alpha, that's going to be 0.05. Okay, so if I'm looking for my Z-score, and this is a two-tailed test, so I'm going to take alpha and divide it by 2. So that would be 0.05 divided by 2. So I have Z equals, I'm sorry, I get ahead of myself here. It's going to be 0.025. So this is what I'm going to look up. I want to know what is the Z-score for this area in the tails, here and here. So we're looking for here and here, because that's our alpha. So I want to know what this is right here. Okay, and using the calculator, it's going to give me this one, so it's going to be negative. So let's see what we have here. I'm going to go second vars, and we're going to do the inverse because remember this will give us that value, and this happens to be, we're looking for a z, so it's a standard normal, which is important. So 0.025, the area, and then the mean. Well, the mean for any standard normal is 0, and the standard deviation is 1. Enter. So again, remember I said it was going to be a negative number, which we should realize that one, negative 1.96. And so we're going to put that in here, negative 1.96. And the negative's not going to matter because we're squaring it, which is going to make it a positive. Okay, so let's use our calculator to figure this out. Let me slide this over a little bit. Okay, so let's see if we can do this all in one. So I'm going to do parentheses and then another parentheses, negative 1.96 squared times 0.5 times 0.5, close parentheses, divided by 0.02 squared equals 2401. So it looks like we would need at least 2,401 would need to be the size of our sample.